Hello, today we're going to be talking about recursion. Imagine want to create a method that plays tic-tac-toe for two players, called simulate tic-tac-toe. Tic-tac-toe is a game where two players fill out O and X alternatively on the 3x3 board until either connects 3 in a row, or the board is a draw. The program should switch between players and keep on running until the game results in a win for either player or a draw. One possible solution is a while loop that keeps on repeating the game until either player wins or all the squares are filled. Though this is a valid solution, is there an alternative, better method? In programming, we can use recursion. An alternative solution is recursion. Recursion is when a method calls its own method, a recursive call within itself. This technique allows for repetitively calling the same method many times, while being able to change its parameters based on what was calculated inside the method. One classic example of recursion is factorials, which are n times n minus 1 and all the way down until times 1. Also, the factorial of 0 is 1, which is the base case, which will be explained later. So the factorial of n equals n times factorial of n minus 1 equals n times n minus 1 and onwards. Let's see this one in action. So say n equals 4. While it's not 0, it will return 4 times factorial of 3, which returns 4 times 3 times factorial 2, and onwards until 4 times 3 times 2 times 1 times factorial 0, which is equal to 4 times 3 times 2 times 1, which is equal to the factorial of 4. So a condition must be set in recursive methods that stop making any more recursive calls at a given point, by making the method not call itself. If this condition is not set, or the condition never runs, the recursive method will run forever without stop. This would lead to a runtime stack overflow error in the program. In factorials, the base case is n equals 0. When n equals 0, the factorial method does not make another recursive call. Therefore, the method ends. So why should we use recursion? For problems that can be broken down into smaller, similar tasks, where each task changes based on the previous task, recursion is the optimal solution. Using recursion can repeat the task in the form of a method again and again, while passing on data from the previous task to the next task in the form of parameters. In tic-tac-toe, the simulation can be broken down into smaller, similar tasks of one player's turn, which involves adding a symbol to the board. The player's turn could recursively call itself until it reaches the base case of either player winning or the board being filled. Each task changes based on how the board changes in the previous one. For example, if the square is filled, the next task will be unable to add a symbol to that square. This information of a filled square could be passed on to the next board in the form of a parameter. One basic example for the recursive tic-tac-toe is a method that has the parameters of a board, squares filled, and turn. These are all base cases that once a condition is reached at either player 1 or there's a draw, the recursive call ends and a value is returned. However, if the base case is still not met, it will first get the player's input for which square they want to fill, then it would recursively call itself using the updated parameters. Also, recursion makes the task more clear and simpler. Using recursion will not require to define a while loop or to initialize some variables required for iterating. As in the first factorial method, a counter, or temp equals 1, is needed to repeat the while loop n times. Also, a while loop is needed when a simpler if-else statement. These aspects make using recursion more efficient to code and look more elegant than other approaches, such as using iteration. However, recursion still has some disadvantages and should not be used all the time.
When a recursive function is called, it stores the formal parameters, return address, and local variables until the base case is met, according to Geeks for Geese. This consumes a lot of memory, usually more than iterative programs, which have no parameters or return addresses. This would be not beneficial as it will probably slow down the program or cause a burden on the system. Both recursive and iterative programs have the same ability to solve problems. All iterative programs can be written recursively, and vice versa. However, recursive methods are sometimes more difficult to understand and are less straightforward as iterative problems. So, recursion may not always be the ideal choice in every scenario. Here are my image sources. Thank you for watching.